Hi. Today for the heat transfer, we are going to look at lab 4, which is forced convection. Okay, let me introduce to you my our team members. Okay, our team consists of 4 people: Muhammad AMIR bin Muhammad SHUKRI, MUHSIN AMILI bin NOOR, me, RUSHAN anak Zaki RANGANATHAN, and also Muhammad AIMAN bin RAZAK. Okay, before going any further, let me take you around our table of contents. Okay, our lab consists of theory, objective, equipment and apparatus, procedures and methodology, safety and precaution, results, discussion, and also conclusion. Okay, now let us look at the theory. Okay, for the theory, what is forced convection? Forced convection is a type of convective heat transfer in which the motion in molecules is generated by the use of an external source for the transfer of heat. For example, exhaust fan or a ceiling fan. The exhaust fan helps to eject the heat inside of the room by generating motion into the air molecules. The rate of heat transfer in forced convection is higher, which can be controlled by an external equipment. Therefore, the system with forced convection has a higher overall heat transfer coefficient than free convection. Okay, this type of forced convection can normally be seen in your PC, where you have an exhaust fan which ejects heat from inside to outside, and it induces cooling to the system. And in other words, you can also see that in exhaust fans which are used in commercial or also houses. Okay, at the right you are able to see the diagram where exhaust fan is used to cause the flow, and then high temperature is also transmitted out. Okay, below that you are able to see the equation that we can use for convection, which is Q equals H times the temperature difference, where Q is the local heat flux density, H is the heat transfer coefficient, and delta T is the temperature difference. Okay, now let us look at the objective. The objective of this forced convection lab is to show the temperature distribution gradient along a pint or fin heat transfer surface in forced and free convection, where we will use the data for forced convection and also free convection to compare how the gradient is in the graph. Okay, and then to compare the characteristic between pint or fin temperature during forced convection, where each surfaces have a different dissipation of heat characteristic. So we are going to compare between the pint and also the fin surface, and this will enable us, when we are applying this to real life situations or during design, this will enable us to choose a more efficient or a more better heat sink, because the pin and fin surfaces are mostly used for heat sink.
Assalamualaikum and very good morning to Prof. Zahir. My name is Mohsin Ivan Rosli. Today I'm going to present the first convection slide. So I will start with the equipment. So the equipment we use is free and forced convection heat transfer equipment. So for the next slide is safety precaution. First is no food or drinks allowed. Second is proper PPE and lab attire is to be worn at all times. Number 3 is stay focused and aware of your surroundings. Number 4 is don't play around in the work area. Number 5, ensure work area is clean and tidy during and after work is done. Number 6 is if there is any accident, inform the engineer in charge. Number 7 is check all joints and connection before starting the lab work. Number 8 is follow all safety operating procedures equipment before starting works. Number 9 is wear gloves when handling any heat. Number 10 is maintain safe distance and sanitize hand before and after using equipment.
Hi, today our group is going to conduct an experiment for heat transfer, which is the forced convection. The forced convection experiment is done by using this apparatus. Okay, so there are a few surfaces which will be used to conduct the experiment. This is a fin, and what we have set up here is the pins. Okay. After this, we will take you step by step regarding the process of conducting the experiment to get optimal data. Thank you.
So first thing we need to do, open the switch of the heater on the back, and then you open the switch over here, and then we will raise the fan speed, the power speed to 30 watt. And after that, we will wait for 10 minutes for the temperature to stabilize.
Hi, once again. Next, we are going to repeat the experiment with the fin, which has been put back into the equipment. Okay. So we're going to start the experiment by following the steps previously to get the optimum results, and there might be also some errors in the experiment, which will be discussed later on.
First, we're going to switch on the power. Then we're going to adjust the fan speed. And then we're going to wait for at least 10 minutes to let the heat stabilize. And then we're going to record the data with the probe.
Okay. Hello. I am IRFAN. So we already finished take a data for pin and fin. After that we already follow the procedure carefully and record the data in the lab to analyze it after our lab session.
So for the result for force convection is heat transfer surface is spin, power is 30 watt, air velocity is 0.0 millimeter per second. So the situation is free convection. So we have 4 different type of temperature data. 3 of them which is we get from the equipment. So the TP, T3, TTS, T2 and Tin, T1 we get from the equipment. And the last is different TP minus Tin, which is we calculate. Then you can see we have 6 different positions. First is position 1 with the length of 7.5 mm. Position 2 is 90.5 mm. Position 3 is 31.5 mm. Position 4 is 43.5 mm. Position 5 is 55.5 mm. Position 6 is 67.5 mm. So we take the temperature based on this position with the probe. As you can see, the temperature is decreasing from position 1 until position 6 for TP, T3. The TST2 also decrease from position 1 until position 6. You can see 65.3. Then it decreased to 55.3. But for the inlet temperature T in T1, you can see the changes is very little and not really big. As you can see, it decreasing by 0.1. Then it maintained until position 5. Then the position 6, it turns to, it have the same temperature as the position 1. So the difference is we calculate for position 1 is 14.7, position 2 is 13.2, position 3 is 12.2, position 4 is 11.2, position 5 is 10.2, and position 6 is 9. So for the next result is the heat transfer surface for fin, and the power is still 30 watt, air velocity is 0.0 meter per second, and the situation also is free convection. So as you can see, we have 4 different type of data temperature. 3 of them which is we get from equipment, and the different we get from calculating by TP minus Tin. We get the difference. As you can see, TP T3 for fin surface also decreasing from position 1 until position 6, and probe temperature T2 also decrease from position 1 until position 6. For the inlet temperature TE91 for fin, the temperature is increasing until position 3. Then it decreasing at the position 4 until position 6. So we have calculated the different TP minus Tin for position 1 is 9.3, position 2 is 7.4, position 3 is 6.4, position 4 is 6.2, position 5 is 4.1, and lastly position 6 is 1.8. And that's all for me, and Assalamualaikum.
So I will start with my part is the result. As you can see, this is table for force convection on pin surface. Heat transfer surface is pin. Power is 30 watt. Air velocity 3.0 meter per second. So you can see probe temperature T3. The highest is 34.2 at position 1. Probe temperature T2. The highest is 44.6 at position 6. And inlet temperature T1. The highest is 30.5 at position 1 and position 6. For different temperature, TP minus Tin, the highest is 3.7. Next is force convection on pin surface. The power same with pin surface, 30 watt. Air velocity also same with pin surface, 3.0 meter per second. And next is, as you can see, probe temperature for T3. The highest is 35.7 at position 1. Probe temperature T2. The highest is 57.0 at position 6. And next is temperature, inlet temperature T1. The highest is 35.7 at position 6 too. And for the different temperature, TP minus Tin, the highest is 0.8. And for discussion, first question is create a chart of temperature, vertical axis, again probe position along the pin of fin. Add pre and post convection result. As you can see, this is the chart for free convection on pin and fin surface. And for for X axis, we put probe position, and X axis is temperature difference. And as you can see, the pin and fin surface is linear. Next is As you can see, this is chart table for force convection on pin and fin surface. And the pin and pin is same linear. And for x-axis, we also put a prop position and y-axis temperature different. That's all from me. Thank you. So I will start with my part is the result. As you can see, this is table for force convection on pin surface. Heat transfer surface is pin. Power is 30 watt. Air velocity 3.0 meter per second. So you can see prop temperature T3. The highest is 34.2 at position 1. Prop temperature T2. The highest is 44.6 at position 6. And inlet temperature T1. The highest is 30.5 at position 1 and position 6. For different temperature, Tp minus Tin, the highest is 3.7. Next is force convection on pin surface. The power same with pin surface, 30 watt. Air velocity also same with pin surface, 3.0 meter per second. And next is, as you can see, prop temperature for T3. The highest is 35.7 at position 1. Prop temperature T2. The highest is 57.0 at position 6. And next is temperature, inlet temperature T1. The highest is 35.7 at position 6 too. And for the different temperature, Tp minus Tin, the highest is 0.8. And for discussion, first question is create a chart of temperature, vertical axis, again prop position along the pin or fin. Add free and forced convection result. As you can see, this is the chart for free convection on pin and fin surface. And for for x-axis, we put prop position, and x-axis is temperature different. And as you can see, the pin and fin surface is linear. Next is, as you can see, this is chart table for force convection on pin and fin surface. And the pin and pin is same linear. And for x-axis, we also put a prop position and y-axis temperature different. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad RAZAK. So by using the gradient formula, we calculate the gradient for each surface for free and forced convection. As we can see, the gradient for forced convection for each surface has lower value than free convection. And other than that, fin surface has lower gradient value than pin surface. What can we say about the difference and which type of convection give better spread temperature? So in general, natural or free convection creates a noticeable difference in temperature, but forced convection creates a more uniform temperature spread. We are able to observe the graph on temperature dissipation between both surfaces in two modes of convection, which is forced and free convection. As we can see, the gradient in forced convection for pin or fin surface is lower because the temperature was spreading rapidly as compared to free convection. The pin surface shows a more efficient dispersion of heat compared to the pin surface, as there are certain criteria such as application and placement which tend to affect the graph. How would using aluminium or copper affect the temperature gradient and the overall efficiency? So compared to stainless steel, which is a poor conductor of heat, aluminium has a good thermal conductivity, which increases the rate of heat transfer between the surface. Aluminium has a good dissipation rate, since in forced convection we need to spread the heat in order to achieve a uniform cooling. An aluminium-based surface would just dissipate heat more efficiently, and via forced convection the cooling would occur more rapidly. This will also increase the overall efficiency of the system. So, conclusion. So, based on this experiment, we are able to learn heat transfer concepts such as conduction, convection, and radiation. Through the lab, we are able to apply basic laws of heat transfer by forced convection on various surfaces be investigated. Other than that, we are able to identify which surface has the best temperature flow rate, and this lab enables us to understand on how forced convection occurs on different surfaces. And lastly, we are able to identify the data which connect temperature and power which acts on different surfaces. That's all from us. Thank you.